Welcome back. Do you know sometimes when you brush your hair and you notice it just gets frizzier and frizzier the more you brush it? Or sometimes when you take a jumper off or a fleece and it makes a little crackling sound, and we sort of describe it as being a little bit staticky. Well, today what I want to describe is what's going on there and what is static electricity. So here's an experiment you can try at home. Get yourself a balloon, blow it up and put it against the wall. And nothing happens. Give it a rub against your hair. And then the bit that you've rubbed against your hair, put it against the wall. And you'll find that the balloon just seems to get stuck there. And in fact, I did this the other day in my lab and it stayed there overnight. So something weird's going on here. It's to do with static electricity. So let's see if we can explain it. So we're going to have to learn some physics to work out why the balloon just sticks on the wall. So there's something else we can do. If you take the balloon and rub it against your hair, you'll notice that as you move the balloon closer to your hair, it gets attracted, and as you move it away, there's less of an attraction, and closer again, it sticks to the balloon. There's a force between the balloon and your hair, and that's an electrostatic force, and it's caused by the rubbing. So clearly, this force gets weaker with distance and stronger as we move closer in. And explaining how it happens, the key must be something to do with the rubbing. So, I've got one of the sixth formers preps here, and if I just tear little bits off it and stick them on the bench, we'll see what happens if we bring the balloon close up to those as well. So, those are the little bits of prep. It's got some physics written on it, and I'll give the balloon a good rub and then just hold it above these bits of paper, and you'll see they kind of flew up to it, which is rather unusual. Got a few more here. Let's see if they'll attract those as well. Yep. So I'll shake those off, give the balloon a little bit more of a rub, and there they go, flying up onto the balloon. So these are these electrostatic forces that I need to explain. Okay, so here goes for an explanation, and this is going to get a little bit technical. I've got a piece of polythene here, a piece of plastic, and I'm just going to rub it with a cloth as hard as I can, and then I'm just going to balance it on an upturned watch glass. It's just going to act as a bit of a bearing. So there it is, and an important thing is it's not touching the table. Here's another piece of polythene, same kind of plastic, and what I'm going to do is rub that as well, and then just hold it near the end of this one. Now, that seems a bit different from what we've seen already. What we saw before was attraction, and here we're seeing repulsion. And I'm not touching them. What I might do is hold on to the end of this, and then bring it near. And nothing seems to happen. But I've got a different kind of plastic here. We call this acetate. It's just a clear plastic. I've made this work with rulers, normal school rulers. Give that a bit of a rub, and hold that by it, and we see the opposite effect here. Now, this is a little bit more like the balloon. We're beginning to see some attraction. So I need to explain what was going on and what's happening when I rub these two different types of plastic. So the first thing you need to know is that all materials are made of atoms. And there are, of course, atoms in this plastic. And an atom, if you remember, has got a positive nucleus and negative electrons orbiting on the outside. And if you think about it, when I actually rub the plastic, if the electrons are orbiting on the outside of the atom, the only bit I'll ever touch is the electrons. And what could be said to be happening is that I'm rubbing electrons off the piece of plastic and onto the cloth. But if I rub another piece of the same material, I'm going to rub electrons off that. So I've removed some of the minuses, some of the negative charge. So this is positive, that's positive, and similar charges repel each other. But if you remember, there was one other thing that I did. I took the white plastic and charged it up and we now know that I'm rubbing electrons off it and making it positive. And I took a similar piece of plastic and also rubbed electrons off that and made it positive, and it repelled. But then what I did was I touched this with my hand. And when I touched it, now it doesn't do anything. In other words, what I've done is I've neutralized this. It was positive, but by touching it, electrons have flowed onto it and balanced out the positive charge, so it's now neutral and has no charge at all. And of course, most materials are neutral, so you don't see these electrostatic effects. It's only when you rub them, and you rub electrons off them in the case of this one, and onto them in the case of this one, that you see these effects. So we now have everything we need to explain why the balloon sticks to the board. I rub it against my head and I rub electrons off the balloon and it becomes positive, and it attracts my hair because my hair has electrons in it, and those electrons can't easily flow onto the balloon because my hair is an insulator. But of course there are electrons in the board as well, or in the wall, because it's made of atoms. And if I take the positive balloon and put it against the wall, the positive balloon will attract to the negative electrons in the board, in the wall, and it will stick perfectly. Hope you enjoyed that video, and I look forward to seeing you next time.